Our next speaker started his career and worked for 3 years at McKinsey & Company, focusing on finance and banking engagements. He got his BS in industrial engineering from Northwestern and his MBA from MIT. He's the co-founder of Enigma, a really cool project working on storing user data off-chain. So please help me in welcoming John Kosigan. Did I butcher it?
Yeah, thanks. Hi, everyone. Here's the... Good afternoon, everyone. My name is John Kosigan. I'm one of the co-founders at Enigma. And as I was introduced, I'm not the senior engineer in the team, but I'll try to appeal to everyone here. At Enigma, we're focusing on the problem of privacy on blockchains. And today, I'm going to tell you about what we're working on, what the protocol looks like, and what we expect to do in 2018. But before getting started, I think all of us here, because we truly believe in the potential of this technology. However, we should be realistic in that we should realize that there's a huge gap between what the technology can do today and the hype we see all around. So at Enigma, what we do is we want to focus on one of the biggest problems that we think can limit mass adoption, and that problem is privacy. And what we do is we're building a off-chain computation network that's complementary to main chains, and we're introducing the concept of secret contracts. And together with these two innovations, we think we can solve the issue of data privacy on blockchains. A bit about us. The Enigma project first started in 2015 when we were students at MIT. And the idea that we were thinking about is, can we build a decentralized computation network that can prove correctness and privacy of data while having scalability features that are comparable, if not better, than traditional blockchains. That led to our white paper, which was published in 2015. Who in the room is familiar with that white paper? Good to see familiar faces. And for those of you who are not, we looked into creating a blockchain where the data is not visible to all nodes. And today, as I mentioned, I'm going to talk more about this. I'm going to mention how the protocol works for us. I'm going to talk about a bit how we, on a high level, store and compute over data in the network. And then finally, I'm going to give you a taste of the decentralized apps people are looking forward to build on top of us. But before we go into it, I'm sure that most people know here what the issue of privacy is, but just to get everyone on the same level, blockchains helped us eliminate centralized trust through a concept of global consensus. That means that every node in the network needs to agree on the final state of the ledger, which you can assume to be the truth. However, while blockchains allowed us to not trust a single rent-seeking entity, it also brought the problem that we need to trust everyone in a network, unknown nodes, with our data. And if you think about it, it actually raises big problems on most of the applications we use today, which somehow deal with private or sensitive data. So when we asked ourselves what happens to blockchain adoption in a world where the issue of privacy is not solved, we decided this is a problem to work on, and that's what we focus on today. So what we're building is a second layer network that is complementary to main chains. And the idea is, if you have an application to run, a contract to run, that is going to take sensitive data inputs, you run it on our chain, and then this way you can guarantee data privacy. We're blockchain agnostic, and our goal is to create a more scalable blockchain ecosystem with better privacy properties. The way our network works is we have our native token, ENG, which is used to run these private computations and also make sure the computations that are run by the nodes are being run in a proper way. So it's very similar to the idea of gas and staking, if you think about it. And we're also introducing this new concept called a secret contract, which feels and tastes a lot like a smart contract. It has an address. It can be deployed by any node in the network. The contents are visible, or the code of the contract is visible to everyone on the network. But there's one difference, and that difference is the data that flows into the contract is not visible to any of the nodes. And so I'll talk about how that happens, but just to walk you through how the protocol works, it's quite similar to some of the blockchain projects we see it. Again, we're a second layer network that complements the main chains. One node can store this secret contract on chain. Once it's stored, it's auditable by everyone. And then data that lives on the Enigma chain comes into this in a distributed way, in an encrypted way. And on this, I'm going to talk more in more detail. Once the data comes, nodes are able to do computations on the part of the data that they hold, and they submit results. There is like a referee system where multiple nodes are likely to run the same computations and submit results. And through a staking sort of incentive mechanism, nodes are better off doing the right computations. And then the way this happens is the presentation before me talked about the sharding, so no need to repeat. We're using a similar approach. The protocol randomly chooses a subset of nodes whenever there's a new data inflow to the system. And a subset of nodes, which we call a quorum, hold to a subset of the data. And these nodes can do computations on it and check each other in a way. And then finally, what happens is the state of the Enigma chain is synced with the main chain from time to time. And if there has to be a dispute on the validity of a computation of the computation on the Enigma network, this claim is done on the main chain. So I told you about a bit how the data is stored. Then a big problem is, OK, we can store the data in different nodes, but how do we make sure that nodes are doing the right computation without actually seeing the underlying data? And this is kind of the area of heavy cryptography. I've heard that earlier today, a lot of people talked about this, so I'm not going to spend too much time about it. But here is an non-exhaustive list of different computation methods that we have out there. We all know about blockchains. We all talk about the scalability problem. We know the performance is low. We know privacy is non-existent, but we know it's it has high integrity due to global consensus, and that you can probably almost run anything on it. Another family this is a partial encryption. This is another scientific term, but it's an umbrella term that we use for different methods such as order-preserving encryption or deterministic encryption. With that, the trade-off you have is you have higher performance, but the data integrity and privacy are much lower compared to some of the methods that I'm going to talk about right now. Then comes like the hardcore cryptographic methods. Fully homomorphic encryption is one of the three. It is a very comprehensive method, but it runs very, very slowly, and it hasn't been really moved out from academia because of performance limitations. I hear there was a full talk about ZK snarks this morning, so I'm not going to go into it too much, but snarks are great if you want to prove a state once and then ask yes/no questions to it. So it's great for applications like Zcash, where you can ask whether there's enough money or not. Another one of these software cryptography methods is called secure multi-party computation. That is what our research was based on. And the idea there is you divide data among the nodes, and nodes do a small part of the computation, and they bring the results together. Compared to other methods, this is much faster than both ZK snarks and homomorphic encryption. And you get good data integrity and privacy with one caveat, and that is if the entire network colludes, then the data can leak out. But you can imagine a world where you can run a node to ensure that this doesn't happen. But one thing to be mindful of, while I said it's much faster than ZK snarks and homomorphic encryption, it is still orders of magnitude slower than computing on unencrypted data. So while not a pure software method, there comes another alternative, which is secure hardware. This is trusted executed environment, or if you're familiar with Intel XGX, this is what it is. With that, you can probably do anything you want. You get amazing performance. However, the problem there is you have to trust that the manufacturer of this hardware is not going to put a backdoor to leak data in. Again, the trust here is not on a node that you don't know, but it's at a company that can be someone like Intel. What we're doing at Enigma is we realize the trade-offs between data privacy and actual performance. So we're focusing on MPC and secure hardware. And this is a developer choice down the road. If we expect applications that deal with very sensitive data, such as identity, etc., to be using secure multi-party computation, we will be using that also for our proof-of-stake method. And for applications that require higher performance, such as being able to do machine learning on encrypted data, we expect secure hardware to be to go-to model. So now that I covered how the network works on a high level, I want to end this talk on a lighter level and tell you a bit about the projects that people are excited to work on, build on Enigma. As I mentioned, we're a second layer network. We work with the main chain, and then on top of us, applications are built which need to have data privacy. One thing that we're very excited about is the concept of building a decentralized bank. If you think about banking, you have credits, and then so credit is how you assess someone's potential to pay back. And with the credit assessment you do lending. If you do well credit assessment, your lending is successful. So one thing we can do is, if you think about the way the current credit assessment works, it's about like FICO score. They look at your bank accounts, how your account changes balance-wise, how long you've had the account for, and then they look into your ability to repay. If you move that concept to the blockchain ecosystem, you can treat different wallets that you own as your bank accounts, and then you can have your payments history as a, let's say, smart contract that does lending for you. Together, this creates a really good application. However, the problem becomes, why would I share all the wallets that I hold with the entire network? I'm OK with sharing that with a bank because I trust that the bank is not going to leak that. So what we can do with our ecosystem is you can ensure the wallets you own in a privacy-preserving manner. And if someone is building, let's say, a credit scoring application on us, one can audit what the scoring mechanism looks like, and your inputs would flow into there without being visible to anyone in the network, and it would still pop out a result that the entire network can reach consensus on. Once you have that, on the other side, you can have anyone basically automates lending via cryptocurrencies, and this creates tremendous access to new source of capital and allows us crypto holders to make use of their money. Another idea that's very promising is around data marketplaces. This is an idea that people entertain a lot. However, one problem with data marketplaces revolves around what happens if someone sells the data that they buy from you. So let's say Fred here has interesting data. I know everyone in the room wants to buy that data. What stops me from buying the data from Fred for 10 and then selling the same data to all of you in this room for 5? There's no way you can stop that from a pure technical perspective. So a way to avoid that is to actually run these computations that come from a data marketplace on Enigma where the data is not visible to anyone. One interesting application of this is a marketplace around genomics data. If you know how, who here is familiar with 23andMe? Okay, awesome. So have you guys done a test there? Yeah. So I think the default scenario is when 23andMe runs a test on you, you pay them. That's general. And then they get to keep your data. What they do is that their main monetization model is then they sell your data to pharma companies, which are looking to do correlation tests between certain proteins and certain diseases. There's this one company that we're in conversation with where they're trying to remove 23andMe from the equation. So they would basically be doing the test for you. They would be giving your data back to you. And whenever, let's say, a pharma company wants to run a correlation with a certain protein that your genome expresses and let's say, cause of Alzheimer, you can actually have the pharma company run this test without ever seeing your data. So that way, you can create a cash flow from the genomic data that you create. And if you think about it, this can have very large implications in that you can create a structure where everyone living in this planet has an economic incentive to get their genomic data, let's say, tested. And basically, this can open a lot of potential and solve one of the biggest diseases, like some of the biggest diseases that we're dealing with, through creating just the right incentive structure and the right technology behind it. So these are the kind of things that really excite us. I am kind of going to wrap things up at this point. Again, we think privacy is a big problem. We're working very hard to solve this problem. We think this is super important for the adoption of this technology. And if any of what I've told is interesting to you, or you're building a decentralized application that is going to deal with sensitive data, or you just want to work on one of the hardest problems in computer science in the blockchain ecosystem, come say hi, we'll be around. You can also, you can also send us a note at info@enigma.com. Thank you very much.